Go. Okay, for today, we are talking about the 1 over x graph. So that, do you know what it looked like? Well, we previewed it the other day. Do you remember me saying that it would look a little bit like a butterfly when it was done? I know that might be a stretch, but it gets closer and closer to the asymptotes that run along the x and the y-axis. So, and to me, that looks a little bit like a butterfly wing, and so does that. And so I call it the butterfly. All right, so there's your standard graph. Now, the 2 points, there's only really 2 important points, that spot and that spot. Now, get used to where they are supposed to be, because do you remember trying to figure out if something's been stretched? You got to kind of know where it should be. Do you remember me saying that over 1 and up 1 was the main spot? It still is. 1, 1. Over 1, up 1. If this graph had been stretched and gone twice as tall, do you get there might have been a dot right there instead? Because that would be twice as tall. All right. Because instead of going up 1, you'd go up 2 to get there. All right, that's always tougher for some people than others, but there's 2 important spots, that spot and that spot. And how can you get them from your XY chart? Well, first off, you put in any numbers you want, but some numbers work nicer than others. So like if you put in x equals 1, and we put the 1 right here, do you get it's 1 over 1? Y equals 1 over 1, which is 1. 1 comma 1 is one of your 2 important spots. If I put in 2, it does not work quite as nice. Then it's got to be a fraction, 1/2. 2 comma 1/2, but that's also on my graph. It'd be like right about here. What was the next nice point? There's really only 2 that will give you integers. Positive or negative numbers that aren't decimals. So give me one more that works nicely besides 1 comma 1. Yes? Negative 1. Negative 1 comma? Positive 1 or negative 1? Negative 1. Negative 1, negative 1. Okay, good. So those are the only 2 points you have to have. Do you remember me in the past saying you had to have 5 points on a typical graph? On these you only need 2, and you need to show that the line goes closer and closer to the asymptotes. That implies you also have to have the asymptotes. So, 2 points, the asymptotes, which are at, that's the y-axis, so it's x equals 0. Don't forget that they change. The x-axis, so that's y equals 0. And then the graph needs to get closer and closer to the asymptotes. All right, so imagine for a moment, next page, that we move that. The asymptotes are going to move too. So if I were doing this problem, the first thing I would do, if I was new like you guys are, is I would put in the asymptotes at 0 and 0, and I would graph the original one, and then I would use your lasso tool to grab it and move everything. Is that right or left on the inside like that? That plus 1 there? That's left 1. How about this minus 4 here? What's that mean? Down 4. So move it left 1 and down 4. Now I'm going to pause for a second while I redraw it because I don't have a neato lasso tool like that. So pausing. Okay, and there we have it. It is moved left 1 and down 4. And if I had to, I could always figure out the 2 key points with my XY chart. It's best friend in graphing. I'd put in a 0 right here because that would make a integer, 1 minus 4. When I put in 0, I get 1 over 1, which is 1, minus 4 is negative 3. 0 comma negative 3, and look at that. It's on the graph right there. And then I'd also be smart enough to figure out that if I put in a negative 2, it would work out pretty nice. Why? How did I get that? Because I was trying to figure out numbers to put in that would make it 1 over 1. In this case, 1 over negative 1. 1 over negative 1, because that's a 1 in there. 1 over negative 1 makes negative 1, minus 4 makes negative 5. Negative 2, negative 5, and there we go. It's right there. Negative 2, negative 5. Okay. So then we should talk about domain and range. Domains you know how they look like this, negative infinity to positive infinity, except if there's something that doesn't work. In domain, it's about the x. As I move from left to right, is there some x number that won't work? Close. Negative 1 is the number that won't work. So I say it works from negative infinity to negative 1, and it stops working. Union, and by the way, on Schoology, it'll be a capital U for union. Negative 1 to infinity. And do you remember how to type in infinity on a Schoology quiz? An inf. Very good. INF. So negative inf, comma, negative 1, parenthesis, union, capital U for union. Negative 1, comma, inf, INF. All right, how about the range? Range goes like this. Negative inf to, where does it stop working? Negative 4, very good. In the y direction, this is the thing it trips over. It's the electric fence at negative 4. And so it won't work there. Union with, and it starts working right after negative 4 and goes to infinity. Okay. The vertical asymptote. Vertical means up and down. That's this one. Remember that's running along like the y-axis, so it's x equals. Another way to remember it, vertical and zertical. Remember how vertical goes with x? Yes?
For the domain and range, do you just use brackets again, or just parentheses?
Good question. For domain and range, then the parentheses versus the brackets mean different things. I am specifically saying that it can't touch negative 1 by using a parenthesis around it. Remember, it's an asymptote. You can't get to that spot. So, yes?
Does it matter which one you put first?
It does matter which one you put first because the lowest number always has to be first. And since both of these had negative infinity in it, you didn't have a choice. You'd have to start with negative infinity. It's the lowest of all numbers. Okay? So if you have two numbers in a parenthesis and a bracket or in a comma between them, the lower number has to be first. Whether it's domain or range, doesn't matter. Okay, so back to the vertical asymptotes. Vertical is vertical, so it's x equals, and that line running up and down is at negative 1. And the horizontal, it's at y equals negative 4. And I want to show you how I get those, and it's so much faster than having to look at the graph. Let me show you. Let me erase this stuff. The vertical is a zertical, so it's an x thing, and it's whatever would make the bottom 0. That's where you get the vertical asymptote from. The horizontal, it's 0 unless there's something on the outside that moved it. Because remember, 0 is where it starts. And then if this is moving the graph down 4, that's where it moves to. So this is the horizontal. This is the vertical. Now, I'm oversimplifying it right now. You're eventually going to learn these complicated rules to figure out exactly where the verticals and horizontals are. But generally, the verticals are on the bottom, and the horizontals are the things that are on the outside. Okay, let's go to the next page. This adds in one more little piece. What's that negative in front going to do? Flip it. Flip it good. Okay. Do you think that that means flip it vertically or horizontally? Okay. We had an interruption there with over the intercom system, but that is a vertical on the outside. That's a vertical on the outside. Do you remember high vote? And this in here is a horizontal on the inside. That's a high. The other ones are vows. Okay, so that's a vertical reflect. Now, let me tell you something strange about these graphs. If I have my graph, wait, pausing for a second here. Okay, so if this is my starting graph, if I do a vertical reflect, do you get that it's going to flip downwards and it would look like that, and upwards and it would look like that? But think about it. If I'd have done a vertical or a horizontal reflect, it would be in the same spot. Think about that for a second. If you take the red one and you flip it left, right, or up, down, you get the blue one. This is one of the only graphs where a vertical reflect and a horizontal reflect do the same thing. All right, so this has a reflect, and I'm not saying it doesn't do anything. I'm saying it doesn't matter if it's vertical or horizontal, because it'll end up in the same spot. And it's one of those like mind benders because you're like, well, I thought it flipped left, right. And your friend says, but I thought it flipped up, down. And you can both be right. All right. But I can tell you this, if it says it's on the outside, then that is definitely a vertical on the outside, and therefore it's over. Vertical things go like this, they go over the x-axis. All right. Let's move on. This one has a stretch. This is the weirdest kind. Now I want you to think about it this way. If it was just a move like this, that would be a move to the right of 1. But then I also said, oh, by the way, I need to multiply it by 2 in front. Do you get that the 2 would end up multiplying by the top but not the bottom? A lot of people think you got to times both the top and the bottom by 2, but think about it. Do you get if you times the top and the bottom by 2, you didn't really do anything? They would cancel, and you'd end up with the original thing you had before. So if you really want to times by 2, you got to times by 2 over 1, and the top will be multiplied by 2, but not the bottom. Get what I'm saying? I get that people think we need to be fair. If we multiply the top by 2, we need to multiply the bottom by 2. But if you do that, you haven't increased the size. You've just changed the numbers, and the ratio is staying the same. So you have to times by 2 on the top and not on the bottom. That was a vertical stretch. Okay, what if I needed a few points on it? XY chart, best friend in graphing. You can always count on the XY to just, I'm going to stick in some numbers. I'm going to try 2 and see what happens. I put in the 2 here. I get 2 over 1, which is 2. Yay, 2 2's on my graph. It's for sure on the graph. And if I try, let's say 0, I put in 0. Then it's 2 over -1, which makes -2. 0 comma -2. That has to be on the graph. Next, do you get that there's asymptotes on these things? I told you that the vertical asymptotes, vertical meaning up and down, were on the bottom. What would crash this function is the vertical asymptote, and that's 1. X equals 1 would be the vertical asymptote. Here's x equals 1. And did this function ever get moved up or down? No. So therefore, this is the horizontal asymptote. It's still at 0. But wait, Mr. Server, I thought you said that you always would start right here and right here, like that green dot. And this one has started up higher than that, the red dot, and lower than that with the other red dot. Do you get that's the vertical stretch of 2 that made that happen? Okay. Otherwise, normally I'd be going through this green dot here, and it's very similar, but if I go through the red dot, it'll look like this. Boy, a lot of people wouldn't be able to tell the difference if you just look quick between the green one and the red one. They're very similar. The only difference was that 2 on top. It's vertically twice as high as it would have been. See, instead of up 1, it's up 2. Instead of down 1, it's down 2. All right, that's everything. So, if you had this on the test, this would be the toughest of them. This does not involve a stretch. Hint, it's generally in the 1 over x category, but it's been moved. I'm going to pause for a second, see if you can figure out what you think the equation of this one would be. All right, back to recording. Can you tell me what equation this was? Well, I would be thinking about this x and say, okay, horizontal on the inside. Was there anything that happened horizontally? That's like the horizon. What happened to the horizon line here? Well, let me think. It looks like it moved up 2. Should I put a +2 in here? No, that's not the right way to think that through. Okay, would you agree that it moved up 2? But then I don't put the +2 there. Where do I put it? Outside +2. And how about How about this move that when it went this way? All right, so that's the 5 to the right, so minus 5. That's the right way to think that through. That's the right, left, that's the up, down. And I told you there was no stretch, so that you didn't have to worry about that. If there had been a stretch factor, it would have gone right here. Let's say there was a 3 stretch factor. How would you have known there was a 3 stretch factor? You would have looked at this spot right here and this spot right there, and you'd have said, oh, wait a minute, there isn't a dot there. Then this thing must be stretched. Well, there was a dot here and there was a dot here, over 1, up 1 from your asymptote origin. Okay, and since there was a spot there, we didn't have to worry about it. There was no stretch. All right. Last one we're going to look at. This one right here. And on this one, there is a stretch. I'm going to show you where there should be a dot, but there isn't. There should be a dot right there, but there isn't. And there should be a dot right here, but there isn't. If this was a normal rational function, there would have been points there. All right, I'm going to pause while you give this one a try. You're trying to write me an equation that involves not only a move in 2 different directions, also some kind of a stretch. All right, I was thinking 1 over x, but it got moved to the right 1 because of this. So then that's minus 1. And it got moved up 3 because of that. And then there was a vertical stretch because there should be something here, over 1, up 1, but there wasn't. And so I have to go up twice as far as normal. There should be a 2 either in the front, like that, or a 2 which would multiply in and go right there on the top. Raise your hand if you had the same thing as I did. Awesome. And if you needed to prove it to somebody, like somebody on a test, or make sure for yourself that you're right, you'd see if that point works. When you put in 1, you ought to get 5. Not 1, sorry. When you put in 2, you ought to get 5. So I'm just going to test that. So I'm putting in a 2, and then this becomes 2 plus 3 is 5. 2 comma 5 worked. I know it's right now. Okay, cool. That's it. Everybody find the Schoology quiz, and we will continue once somebody can read me the first. Well, actually, it's a picture one. I don't know if I'll be able to call that up on the iPad. How about this? Somebody find the first quiz of the Schoology, first question of the Schoology quiz, and tell me what the questions are at least, and then I will start answering the first question of your Schoology quiz here. You found it? What does the first question ask for?
Determine the horizontal and vertical asymptotes as well as the domain and range for the graph shown below.
So was the first question horizontal asymptote? Like with the first blank, where's the first blank in there?
Yeah.
So it says horizontal asymptote is at, and then what does it exactly say? Blank.
Blank, and there's one for vertical asymptote.
Oh, okay. All right, horizontal, vertical asymptote. Can you guys tell me? Horizontal is the one that's like the horizon, okay? And those are like the x-axis, so they're y equals things. So it would be y equals, what is it? Y equals 0. Anybody verify y equals 0? Okay, good. On to the next one, the vertical asymptote. Those are up and down things. Has that been moved, or is it just at 0 still? Ah, it's been moved to 3. So vertical is zertical. X equals 3 would be the second blank then. All right, Mr. P, can you tell me the third question?
The domain.
Domain. I'm going to give you guys a hint. Domain always starts at negative infinity. And on a rational function, you've always got some number that won't work because it's got that asymptote thing going on, right? And it ends at positive infinity. So they're always going to look like this. The only question is, what's that one number that won't work? And you put it here. So what is that one number? Miss T.E. in the back row, underneath the fish. What do you think is the one number that the domain, which is the x's, can't be?
Oh,
3 is correct. All right, then the range, always, again, on these things is from negative infinity until positive infinity. Oh, wait, I wrote a number. Dang it, it's got a U in the middle, and it's a capital U. Go insert that back in there, otherwise that won't give you credit. You need a capital U in the middle. U, like that. Okay, and what is the one number that the range can't be? Hint, it's a y equals thing, and I already have it written down on the page. It's right there, 0. Now, if I was doing this on the Schoology, I would be typing in INF for infinity. So negative inf, comma, 0, union 0, comma, inf. And don't forget to use a capital U for in between. That's the union symbol. All right, that's all I have for you for the video for today.